For this lab, we were told to create a digital clock, which was made up of four different modules, or four main modules, which were current time, set alarm, and then the format for 12 hours or 24 hours. But then you have other modules, such as the top modules and debouncers and whatnot, to incorporate them all together. But for now, I'm going to be talking about two of the modules I actually created. The set time module, which has one input of a push button and three outputs, I'm sorry, which are then the inputs to the current time. So I'm going to be talking a bit about the set time module and the set alarm module, which are both really connected. So in terms of the set time module, so this is a clock, you want to set the time, you have an input of the push button and the switch, because the push button will be to increment when you want to set the time, and the switch would be to choose which aspect you want to increment, whether it's hours or the minutes or the seconds. So those are going to be our outputs in this case, H in, M in, and S in, and you have the clock and reset. So you have your always block at the positive edge, and at the reset you begin. If the reset is 1, so you're just gonna have all the outputs being 0, and then if not, so if the reset is 0, you're gonna begin an if statement on the push buttons, and so you're gonna do a case on the switch to see which aspect you're going to be incrementing, whether it's hours, minutes, seconds. So it's going to be 2 bits of binary, either 0001 or 10. For each case, you have either hours. If it's 00, you're going to have hours, and then that's going to be h in plus 1. So you're incrementing 1 each time, and then for minutes and seconds the same. And then the default is just going to have h in equal h in. So that's for the set time module, which is so that has the push buttons as input and the switch, of course, and then 3 outputs of H in, M in, and S in, which are then going to be the inputs for the current time module. But I'm going to talk a bit now about the set alarm module. So this is to basically just set an alarm on your clock. So you're going to have an input of the push button, and the switch, of course, clock, reset, and then you're going to have H out, M out, and S out, which are the outputs for the show the current time as outputs. And you're also going to need an output for your LED, because that's going to be your alarm system for this clock. It's going to flash the LED when the alarm is off, or set, I mean. So basically for this, you just need to call the set time module. That's why I was saying they're very similar, because it does the same thing exactly. You're just gonna either increment and choose with the switch which aspect you want to control, whether it's hours, minutes, or seconds, and then with the push button, you're going to be incrementing by 1 to set. In that case, you're setting the time for the first module, but in this case, you're going to be setting the alarm. So it's basically the exact same thing. So then the only difference now is you're going to be adding this aspect here for the LED, whether it's to light up or not. So for the positive edge of the clock, if the reset is 1, LED out, which is going to be the output for the LED, is going to be 0. That's if it's on reset. And then anything else, if H alarm equals H out and M alarm, M out, if all those equal, then the LED in fact will be on, and that's going to mean that the set time that was put for the alarm is when it's equal to the output of the current time, which is the current time that's going to be showing on the 7-segment display. When those two equal each other, so for the hours and minutes and seconds, then you're going to have your alarm being set, and you're going to have the LED output on 1. Anything else would be 0.
I'd say a success from this project was figuring out how to work this counter here and get it to like display the different modes, like the time format, as well as piecing together the modules that I created with the modules that Seifallah made, because since we live in different time zones, we work at different hours. So we had to kind of piece together our modules in our top module, which ended up working out rather well. We were able to piece everything together well and display it where we had to. And a failure, however, I'd say, was that our clock, when implemented onto the FPGA board, isn't very intuitive. If you just give it to like a random person and tell them it's an alarm clock, but don't tell them like which buttons you're supposed to use to operate them and like the specifications essentially of the alarm clock, they'll probably have a difficult time figuring it out, just because it's not super intuitive to a new user.
Here's the demo for the alarm clock. Currently the clock says it is 2:35 in the morning. We can turn on the 12-hour. You'll see the A for AM. By holding this top button here, we'll go into set time mode, and we'll change it to 1 p.m. So we gotta change this, increment it up to 13. Perfect. We'll keep this at 35, and we'll keep the seconds as is. It's still counting as we go. So now the time is 1:30, I believe 1:36, a bit past 1:36. So we'll also set an alarm. And we'll set an alarm for 1:38 p.m. Should be enough time. Uh, 1:38 and 28. So now if we go back to our clock, you can see it says 13:36 and 44. If we change the 12-hour clock, you'll see 1 p.m. And now we'll just wait until it says 13, 38, 36. It's a whole minute away, so I'll probably edit it. There it is.